Welcome to MrCScience.com's video on average and instantaneous velocity for our physics class. We're going to talk about the difference between average and instantaneous velocity. We'll deal with speed as well, but usually in physics we call pretty much everything velocity. If we don't deal with an exact direction, there's always an implied direction. So um, we're going to talk about that. Uh, there's an experiment on here to kind of show you how to do it. I may not do that as kind of a simple experiment. It works better just to talk about it. Let's take a look. In the experiment, you've got yourself a ramp and you've got a ball. You put the ball on the top of the ramp, you release it, and you time the amount of time it takes to get the first half of the experiment is halfway down. The second half of the experiment is how long it takes to get to cross the second half, and then you got the total length of the board. So they use this to define its velocity. Velocity, whoops, use my pen. Velocity equals distance over time. So the distance that it's gone versus the time. So here's our distance here. Distance is always written as a lowercase d. The distance of the ramp. And then we're going to record the time it takes to travel that distance. So if we grab our ball, so it makes the path from the top of the ramp down to the bottom. So it travels this, not quite that curve, but it travels down the ramp in a certain amount of time. So we can figure out its velocity. So let's say that distance d equals, let's say it travels 1 meter, about 3 feet. And the time it takes to get there is, let's just make it simple, 1 second. So what's its velocity? V equals distance over time. 1 meter divided by 1 second equals 1 meter per second. Simple, right? Well, what is this velocity? And where is it at that velocity? So is it at the velocity here at the bottom? Is it traveling at 1 meter per second? Is it in the middle? Is it somewhere along the way? So instantaneous velocity is along the way. So at the very beginning, the very millisecond we let go of that ball, what's its original velocity, or its beginning velocity? Well, it's not moving, so it's 0 meters per second. When it hits the bottom of the ramp, we don't know. It's going a certain amount of meters per second. Now the time, it covered this distance in that amount of time, so this is actually an average velocity. Its average velocity was 1 meter per second. So we can figure out what this is, its instantaneous velocity at the bottom, by understanding what average is. Average is the sum of all your units or your data divided by the number of units or data. So in this case, we label these. So beginning velocity is often labeled V0. We'll make it a science 0, put a slash through it. Or no, sorry. Let's label that V initial. V initial, it's initial velocity. At the end, where we finish reading, it's VF for V final. So our average equals our final velocity minus our initial velocity divided by, we have 2 readings, divided by 2. So if we use this, V final minus V initial divided by 2 equals your average velocity, or we'll say equals V average. So using that, we could figure out what velocity it was traveling here, because we figure out its average velocity is 1 meter per second, right? So what we can do is we can plug everything into here. So there's 2 different ways to do this. We can, why don't we try solving for what we're looking for first? So we know what V initial is. We're looking for what V final is. So how do we solve for that? Here, let's give ourselves a little bit more room. Okay. So we want to rearrange the equation. V average equals V final minus V initial over 2. So here's where the algebra comes into play. You should be relatively familiar with algebra. I'm going to get rid of that. There we go. So first thing we want to do, get rid of this 2. In order to get the 2 off the bottom, we multiply both sides by 2. Anytime you do the same thing to both sides of an equation, you do not change the equation. So we end up with 2v average equals v final minus v initial. Now we want to find v final, so how do we get rid of the minus v initial? Well, we add v initial to both sides. And we end up just kind of rearranging here. V final equals 2v average minus v initial. Okay, now we can plug in our numbers. Equals 2 times our average velocity was 1 meter per second minus our initial velocity 0 meters per second. Oops. Multiply that out. 2 times 1 minus 0. Our v final is 2 meters per second. So we know that it was going 2 meters per second at the end if it has an average velocity of 1 meter per second. And that makes some sense because if you think about average, especially with 2 points, it's always halfway in between. So its average velocity was 1 meter per second. Its its instantaneous velocity at the bottom of the board is 2 meters per second. So that's the difference between average and instantaneous. So instantaneous is often very difficult to record. You have to actually calculate it most of the time. So where average velocity is simple if you got distance and time. Okay, I'm going to move on to the next concepts in the next video, but if you have any questions on this video, feel free to contact me at mrc@mrcscience.com. Thanks.